write an expression in explicit form for this sequence. We have 4, 9, 14, 19. So I'm going to write this in a table so it's easier for me to find a pattern between the term and its position. So here's position 1, and the term that occupies this position is 4. Term number 2 is 9, and term number 3 is 14, and term number 4 is 19. Okay, so I'm trying to establish a pattern between the position of the term and the term itself. How do I get from 1 to 4? How do I get from 2 to 9? How do I get from 3 to 14 and from 4 to 19? So we try to look at how we can relate these two things. I start by writing a sub 1, a sub 2, and I said in a previous video that the first term is, this is equal to 4. That the first term is usually the hardest to find a pattern for. So I like to start at the second term and maybe third and fourth terms, and then I go back to the first term. So the fourth term is 19. And what I do is I try to rewrite this in terms of n. So a sub 1 is 4. I can think about 1 getting to be equal to 4 by multiplying it times 4 or adding 3. A lot of things can happen with that first term. So I'm going to skip over to the second term. If I look at 2 and 9, I don't know about you, but I see 2 times 4 equals 8. I try to get close to 9 by multiplying 2 to something that will give me a value close to 9. So 2 times 4 is 8. I could say 2 times, or the position times 4 will give me 8, and then if I add 1, I get 9. Let's see if that works for the third term. 3 times 4 is 12, but then if I add 1, I don't get 14. So what the pattern that I found here doesn't work for this one here. So I try something else. How about 2 times 5? 2 times 5 gets me really close to 9, and then I'd have to subtract 1 to get a 9. So let's see here. If I multiply 3 times 5, that gets me really close to 14, right? 3 times 5 is 15. So I can subtract 1. So I'm seeing a pattern here. Let's go ahead and write what I found down so that I don't lose track. To get from 2 to 9, I'm going to multiply times 5. So 5 times 2 gives me 10, and then to get back to 9, I would have to subtract 1. Let's do the same thing with the third term. 5 times 3 will give me 15, and then if I subtract 1, you get 14. And let's do the fourth term. 5 times 4 is 20, and then if I subtract 1, I get 19. So I see that this pattern works. Let's look at the first term. If I multiply 5 times 1, which is the position, that gives me 5, and if I subtract 1, I get back 4. So it works. I have found a pattern, and I'm going to try and highlight what I found. This is what we did. We took the position, here it is, the position, and we multiplied it by 5. And then we subtracted 1. And we took this position, here it is, and we multiplied it by 5. And notice that this position number I've used to find the pattern. So when I go ahead and write the nth term, I'm going to write 5, which is constant. I'm going to write this number here, which is not constant, it varies. I'm going to write it as the variable n, right? Because this number is identical to the position number. So if I've labeled the position n, I'm going to label this variable n also. And then minus 1 for all of them. And there is your expression in explicit form for this sequence. I'll give you more examples in the next video.